Welcome to Calculus Chat, a weekly discussion with your lecturers for 114. I'm Dr. Biggs, and here with me is Dr. Kellerman
Hello.
and Professor Van der Walt.
Hi.
Ah, we've made it halfway.
Yeah, 8 weeks over. Can you believe it?
Indeed. I'm not exactly sure when our students will be listening to this, maybe during the break, maybe after the break, but we are recording this the day before the break. So we are very much looking forward to the week that we all, I think, need and deserve to just recalibrate a little bit and re-energize.
Yes, I'm sure you can hear the anticipation in our voices.
Mixture of exhaustion and great joy.
Yes.
The word break is actually an interesting so-called contronym, which is a word that has two contradictory meanings, like the word left can mean to remain or to depart. And so the word break can signify destroying something, but it can also mean allowing a person to recuperate.
Yeah, indeed.
Well, let's hope that nothing and no one has been broken so far, and that we're all going to recuperate.
Indeed. And yeah, I mean, I think this is perhaps not a bad time for students as well to really take some stock of where they are, to think a little bit. I mean, this is first year of university, right? Where is it that you want to go? Right? Often I think you come to university with certain ideas, but then after you start experiencing life at university and life out there, those ideas might change. And that's very natural. That's what's supposed to happen. And you need to give yourself some time to think about that, to reflect about that, to sort of ask yourself, well, what are the things you have passion for, and what are the things you want to pursue in your life?
Yes, I could share a personal anecdote. I did not start off studying mathematics when I came to university.
Uh-huh.
My actual desire when I was in high school was to study physics because, like the nerdy little boy that I was, I read all of Stephen Hawking's popular books on physics.
Same, yeah.
I got charmed by all these fantastic ideas, and I was going to become a theoretical physicist and, study quantum mechanics and all these wonderful things. But then
Yep.
I was convinced by other people that I should rather study actuarial science. And yes, so this is where I started out.
Okay.
This turned out not to be for me.
Mm-hmm.
So it's a wonderful program, but it was the wrong one for me.
Yeah.
So the maths I did well in and I loved it. But then some of the other things I did not love and I did not do so well in them, to put it mildly. Um, and then I changed to mathematics, and that was one of the best decisions I've ever made. So again, that was a good decision for me. So I think it's good that our students realize that. I mean, you're not even 18 when you make the decision what you're going to study at university.
Yes.
And I think when you're 18, you don't necessarily have the best idea of what is out there
Mm-hmm.
and of what the thing that you've decided upon actually entails.
Exactly.
So there's no shame in deciding that whatever, if you decide that the thing you're studying now is actually not the thing that you should be studying.
Yeah, that is perfectly natural. And for me, I
Yeah.
mean, that's part of a university experience, is to get wider exposure and to learn what these fields are like, and where your passion lies.
I had a very similar experience when I was in school. I also wanted to become a physicist.
Oh, wow, there's three of us, yeah.
And then I decided in high school to become an actuary because that's what people told you. If you were good at maths, you should become an actuary. But then when I was in what today would be called grade 11,
Mhm.
in my day it was called standard 9, that's when I fell in love with mathematics because I think that was a turning point. That was the year that the mathematics became much more interesting.
Hmm.
And so by the time I left high school, I decided I wanted to go into mathematics. And I think it's a good career choice. Our previous head of department and dean, Professor Lebuma, always says he's never heard of an unemployed mathematician.
Indeed.
Well, I have heard of one, but that's because of by choice.
Aha.
The Tadelman who solved the Poincaré conjecture is not actually working at that point. I don't think was working at the university. If I could be wrong,
Mhm.
but I think so. But that was his choice.
Okay.
because he was rebelling against the system.
So it sounds like I'm the only one that stuck with physics up onto university. I managed to get all the way to second year before I realized that no, actually, what I was really enjoying in physics was a lot of good maths that they were applying. But maybe the heart of the physics was not where my passion was. And then I switched over fully to mathematics.
Now, Richard Branson gave the advice you should write down a table with 4 columns. In one column, you should write down the things that you're good at, in another column, the things that you're not good at. In the third column, the things you enjoy, and in the last column, the things you don't enjoy. And this will help you decide if you're on the right path and what the
Hmm,
right path is.
sounds like sound advice.
Mm.
So we will also be sending out some messages to our students to help them formulate a little bit where they stand, at least with respect to 114, where they hit it, whether they need to make some changes going forward, whether they're on track. And I believe our faculty student advisor, Dr. Paul Madi, is also arranging an information session where he will share some of the possible paths open to our students, either to carry on further with mathematics or to, well, end up going somewhere else if this is not where their passion lies. And I mean, that's fine. That it takes some learning to see whether this is indeed something you want to do or not.
Yes, I want to encourage students to attend the session with Dr. Mahdi. He's got a couple of years of experience advising students, and especially students in maths intensive disciplines.
Yeah.
Um, he can help put you in touch with study groups, help you with study advice. So I really want to encourage the students to make use of this opportunity.
Yes, a lot of success in your studies also depends on good study techniques. That can be the difference that makes or breaks your studies.
Yes, for me, there is nothing more sad than when you have a student and you can see they've been putting in a tremendous amount of work and a tremendous amount of time, but they've just been doing things the wrong way in unproductive ways. And that always breaks my heart. Okay, so I hope students will use this chance and this pause in this semester to reflect and to make a
Mm.
good plan for what are their goals and what they want to do going forward.
Mm.
But let's return to 114 and discuss a little bit what's been happening there. So, in lectures, we now finally did the inverse of functions, looked at that in a bit more detail, and then used that kind of formalism to get to the inverse trig functions and their derivatives, as well as introducing the logarithms as the inverse of the exponential. And we also, during this time, did a little bit about implicit differentiation, which is, for me, quite a nice, powerful idea. I mean, just the idea of an implicit function, to not have a function explicitly written as a formula, but implicitly like, okay, it's the solution to some equation. And there's all kinds of things you can do with functions implicitly defined, even if you don't have an explicit formula for them.
Yes, I think this is something somewhat of a shock to many people when they encounter this idea first, that most functions are not actually given explicitly by formulas.
Mm-hmm.
And there's a distinction between a formula and a function. So you've got these implicitly defined functions, but then there's at least still some kind of a formula. You've got an equation,
Yeah.
but there are functions for which, I mean, of course, you can just invent a new notation to donate this specific function. But there are many functions, like, one of the standard facts of, say, the theory of partial differential equations, which is an important, well, it's basically the main way how our physical reality is modeled mathematically, is through
Mm-hmm.
partial differential equations. And it is highly unusual to encounter a partial differential equation, especially one which is physically relevant,
Mm-hmm.
for which you can actually write down an explicit formula for the solution.
Yeah.
Usually, the best you can say, and even with some relatively simple equations, we're not even sure if we can say this, is that a function exists that satisfies the equation. That's it. No formula.
Yeah. And yet, that is still something useful to be said and something good that you can do with that information.
Yes, it's a key step in addressing whatever problem you have, because what you would typically do, instead of trying to write down a formula, you would rather try and compute numerical solutions or numerical approximations for the solution. But whether the methods you would apply to get these approximations work depend on A, whether you actually have a solution,
Yeah.
because if there's nothing to approximate, then what are you doing? And it depends secondly on how nice the solution is.
Yes.
If the solution is not nice enough, then your numerical methods will either give you not converge or not give you good approximations, or the approximations will converge so slowly
Hmm.
that the method is practically useless.
Yeah. Yeah. So, I mean, even if you don't have it explicitly, you can still say things about it and study
Absolutely.
that object, and that can still be very useful.
Yes.
Okay, and then in Tuts, well, I think we were mainly still mastering our differential toolbox, as I like to call it.
Yes.
I think practicing all of these differentiation techniques so that they almost become second nature to our students is quite an important part of this module. Is there's quite a few very mechanistic things like applying the quotient
Mm.
rule, applying the product rule, finding the derivative for simple functions that as you go on in mathematics, we're just going to expect that is something you can do, like adding 2 plus 3 and saying it's 5, to say that the derivative of this is that.
Yes, absolutely. And as one of our colleagues, Dr. Messerschmidt, likes to say, how do you differentiate a function? You look at it and then your hand starts writing. You don't even have to think about it. And of course, it's not like that when you start out,
Yeah,
but by the time you get to the exam, you should have done so many differentiation problems that you can literally just look at the thing and differentiate it. It should become a reflex.
indeed. Okay, so where are we going when we come back after the break? Well, we're going to be finishing off our theme 3 already, with quickly talking a little bit about logarithmic differentiation. So, how to maybe use logarithms in a clever way to differentiate some things that at this stage we can't differentiate yet. And then quickly take a tangent off to look at hyperbolic functions, which can be defined in terms of the functions we already know, but are useful to define nonetheless.
Yes, and that's the end of theme three.
Indeed. And then we immediately start with theme 4 for the second two lectures in that week, which is, well, theme 4 is going to be all about applications of differentiation, right? We've got this great toolbox we've developed now, and we're going to develop a little bit more theory about, well, what can you do with derivatives and what meaning can be ascribed by knowing the derivative? Things like, well, the obvious one that our students have long been expecting is, if we know that the derivative is positive, can we say that the function is increasing? We want to do all the details for that.
Yes, and then it's maxima and minima, big application of calculus, optimization problems, things of that sort. And of course, we're going to do an application to mathematics, right? We're going to do L'Hopital's rule,
Oh, yes.
which is an application of differentiation to the evaluation of limits.
Yeah.
So we mathematicians consider this an application.
Yeah, calculus is, well, not calculus, but mathematics, pure mathematics is sometimes said to be both the master and slave of science. Master because it's the most fundamental science, and slave because it derives its value from its applications potential.
Indeed.
And when we do these optimization problems, that's really a big area where mathematics earns its keep in the landscape of science.
Yeah. It is amazing where that kind of problem crops up just in so many places.
Yeah, well, it's a fundamental question. You know, what do I've got a business. What do I do to maximize my profit?
Hmm.
Or, I'm a municipality, and what do I do to minimize water loss due to leakage in my pipes? Or
Hmm.
I want to reduce my electricity bill at home. You know, what's what's the optimal strategy to follow, bearing in mind the cost of what I'm doing.
Yeah. No, and I mean, and sometimes it's also not just even a direct thing like you want to maximize something, but it's that you can formulate that some biological process or some physical process works in a sense, in a way that optimizes something.
Yes, that's an interesting perspective, that things work in such a way that they work best. And then you can deduce properties of the system from this principle.
Mhm. So the long promised and awaited Professor van der Berg is going to make an appearance in those first two lectures, at least, well, for the first six, when we're going to be reusing some of his videos. But Dr. Kellerman will be in charge of remastering those for us. So he might also give us a slight introduction there.
Yes, so for lecture units 4.1 to 4.3, we'll be using some of Professor Vandenberg's videos from last year, 6 videos initially. And these are very excellent videos. It's a wonderful opportunity for students to see another perspective.
Indeed. So lots of fun awaits our students when they come back from their break, hopefully rested and re-energized. And I hope they do make use of this time wisely to recharge and to think about their futures. Okay, until we see you again next term. Cheerio.
Bye.
Bye.